talk to me about connected objects. There is an object that went pretty far away from our brains. It went on Mars. And there is a rover right now connected. And there is someone who has written the software for that rover to connect it to the NASA center. And so I'm so thrilled to have Ben Cichy, who wrote the software for the Mars rover, and he's going to explain us how he made it and take us into a journey. Ben?
Good morning. I thank Loic for the nice introduction. Now I'm here today to talk to you about Mars. And if it wasn't for that introduction, I would think that a lot of you would think that I was maybe in the wrong place. That maybe, what does Mars have to do with the Internet of Things? What does Mars have to do with connected objects? And so today, I'm going to tell you a story about Mars. And the story of Mars is very much about connecting people, about connecting rovers sitting on the surface of Mars hundreds of millions of miles away. So for much of our history, Mars was nothing more than a reddish point of light in the sky. And it wandered across the sky in a regular orbit. It stood out from the stars because of its color and because of its motion. But we didn't know much about Mars. All we knew was that it was the next planet out from the sun. And Mars was very much like Earth, as far as we knew. It had seasons. It had polar ice caps. It had a frigid northern winter and a temperate equatorial summer, and maybe even a rainy season, a Parisian rainy winter, but not that we know of yet. So Mars has always fascinated us. It's about half the size of Earth. It maybe once looked a lot like Earth. And so when we look at Mars, we start to ask ourselves, was Mars once like Earth? What can Mars tell us about ourselves? And it wasn't really until the 1870s where anyone tried to really map Mars. And in that area, an Italian astronomer named Giovanni Schiaparelli, he created the first real map of Mars. And through a telescope, through long nights, while Earth and Mars were as close as they've ever been, he was able to map out the surface of Mars. And what he saw was when Mars came into focus, he saw a network of channels on the surface of Mars, these features that covered the surface of Mars, all these channels. And he drew this map where Mars was now this live place with these channels that crisscrossed across the surface. Now, when he published his discoveries in his map, he used the Italian word for channels. He used the word canali. And an American businessman, Percival Lowell, he looked at this and he said, canali, these are canals possibly because of a mistranslation. He said, there are canals across the surface of Mars. And the only way that we can have canals created across the surface of Mars are by intelligent beings, canal makers that are on the surface of Mars creating these canals, this vast irrigation system to pull water from the polar caps of Mars and transport it down to the equatorial regions where there's no water. And so it was very much through Percival Lowell and through the observatory that he founded that the public first started to get excited about Mars. They first started to think, could there be life on Mars? And first started to look to Mars to answer some of the big questions. Could there once have been life on Mars? Is there life on Mars now? Are we alone in the universe? These are the kinds of questions that we ask when we look up into the sky and see that point of light crisscrossing across our night sky. Now, it wasn't really until the advent of the space age that this point of light really started to come into focus. And so across the 1960s, we started our first attempts to go to Mars. Now, these first attempts were, well, really nothing short of failure. In fact, the first 12 missions that we tried to send to Mars failed in utterly spectacular ways. They didn't separate from their rockets that were launching them to Mars. They miscalculated the trajectory to Mars and crashed into the surface. We didn't understand the secrets that Mars had for us, how to understand Mars, how to really get to Mars and to land on Mars. And it wasn't until 1965 that we got our first glimpse, our first up-close glimpse at the surface of Mars. And it was from the Mariner 4 spacecraft, and there were 21 images that came out of this encounter. 21 images for our first pass through Mars. And when we saw these 21 images, what was remarkable about them was there were no canals. There were no channels. Mars looked much more like our own moon, pockmarked with craters and a global dust. And it didn't look to be this live planet. There were no Martians looking at us up from Mars, back down to Earth. There were no signs of life at all. But yet we still wondered, well, maybe it's just that this flyby was too fast. Maybe there's something more to the secrets that Mars has to tell us. And so let's try to land on Mars. So in 1975, the US conceived the Viking Program. And the Viking Program, the objective was to land 2 landers on the surface of Mars. Now, these landers were much like the landers that we used in the Apollo program. They were legged landers with a series of, that would touch down softly on the legs of the lander, and then from the top of those legged landers, deploy robotic arms to go sample the surface of Mars. And so this was our first attempt to really use what we had learned from all of those failed missions to land safely on the surface of Mars. And it was a spectacular success. And in 1976, we returned these first images. This is the first image ever taken from the surface of another planet. And here we see just the foot of the Viking Mars lander depressed into the Martian soil. And it was with this image and the images that followed, like this color image from Mars, the first color image from the surface of another planet, that we started to see that Mars really was a dusty, rocky, barren place, that there wasn't life as we could detect it in those missions on the surface of Mars. And so we retreated. And for 20 years, we really didn't send any more robotic spacecraft to go explore Mars. We stepped back, and we looked inside for the answers to these more fundamental questions. And one of the things that we learned in those 20 years was that life on Earth can survive in all sorts of places that we never imagined that it could survive before. And in fact, all that we need for life to thrive on Earth is 3 basic things. We need an energy source, like the sun. We need water, liquid water. And we need the building blocks of life, the organic material that can build up what we are made out of. And so those 3 things are all we need. So we decided to go back to Mars, and maybe hidden underneath this barren, rocky soil could actually be these ingredients that we know now would be all that would be needed to have life on Mars, either in the past or the present. So, but what we also realized was we couldn't go back to Mars the same way we had gone before. We couldn't afford the types of propulsive legged landers like the Viking system had used. So we decided to come up with a whole new disruptive technology for landing on Mars. And we decided to, instead of taking the lander and landing it softly on its legs, let's wrap that lander in bubble wrap, essentially, and bounce it across the surface of Mars and let it roll until it is safely down on the surface of Mars. So we created these 5-meter tall airbags that would cushion the safety of the lander safely as it bounced across the surface of Mars. And we thought, hey, while we're at it, let's not just go with one disruptive technology. Let's take it a step further. Let's include inside of these airbags not just a legged lander like the Viking lander. Let's include in it the first ever planetary rover. And so in 1996, we landed the Sojourner rover on the surface of Mars. And this was the first rover ever to go out and explore the surface of another planetary body. With this rover, we were able to go and really ignite the imagination of the world. This was the first major Webb event ever to happen, was the landing of the Mars Pathfinder lander and the Sojourner rover back in 1996, right when the Webb was getting started. Here now, we galvanized the attention of the internet towards this one event of exploration. But it would be another 8 years before we actually went back to Mars. Now, we tried in the intervening time to land again, and just when we thought we were masters of Mars, just when we thought we could do anything, we could land on Mars, we've understood this, we've landed Viking, we've landed Pathfinder, we know how to land on Mars. In 1999, we had 2 catastrophic failures trying to land on Mars. And that with the Mars Polar Lander and the Mars Climate Orbiter, we all of a sudden understood maybe we don't understand Mars. And it wasn't until Spirit and Opportunity landed on Mars back in 2004 that we were once again able to explore the red planet. And Spirit and Opportunity were wildly successful, returning images like this. This is the image of Opportunity when it landed on the surface of Mars. And one of the great things about Spirit and Opportunity is that they were able to answer that second question we had, look for that second ingredient of life. They were able to look for water and find evidence that Mars once was a very wet place. Opportunity here found that just right by a couple of meters away from where it landed, an exposed chunk of bedrock that told us that, wow, there once used to be a shallow, salty sea across this region. And so now we knew we had an energy source, the sun. We knew we had water that once existed on Mars. And not only did water once exist on Mars, from 4 years later, we landed another lander on Mars. And this lander, the Phoenix lander, told us, hey, there's actually water on Mars right now. Now, it's not liquid water, it's frozen water near the northern pole of Mars. But right under the northern pole of Mars, a couple inches under the dirt there, we can allow to scrape it away, and we can see that there's water on the surface of Mars. And so now we know we had 2 ingredients, but we stepped back. There was still more questions about Mars than there were answers. We still didn't know whether or not there could be all of the ingredients we know we need for life on Mars. And so we had to build something bigger. We had to build a Viking lander, but one that could drive around, one that could go explore the storybook that Mars had to tell us, and look for those ingredients of life, look for whether or not there's an environment on Mars that could support life. And so we built this. This is the Curiosity rover, and this is the rover that I work on. This is the mission that we sent to the Red Planet just over a year ago. We launched it out of Florida. And so this is the most massive rover we have ever created. This rover weighs as much as a small car. It weighs 1 metric ton. It's just over 2 meters tall, 3 meters long, and 3 meters wide. It has a 2-meter robotic arm out on the front of it. It is the most capable rover we've ever sent to another planet. And it's an international rover. This rover has 10 science instruments. It has an environmental monitoring station from Spain. It has a radiation detector that was developed in collaboration with Germany. It has a water detector that was built in Russia. And it has a laser that was built here in France that from 7 meters away can zap a rock, look at the spark of plasma that comes off of that rock, and tell us what that rock is made out of. The rover can drive over obstacles that are half a meter tall. It can drive up slopes that are 30 degrees. It is the ultimate off-road vehicle. But the problem that we had is that we developed this rover. We knew that we needed this rover to find that last ingredient of a habitable environment on Mars. But when we developed it, we realized pretty early on that we didn't know how to land it. We didn't know how to actually get it to Mars. Now, we knew some of the pieces that we would need. We knew that we would need a protective shell to protect the rover as it traveled to Mars. We knew that we would need a heat shield to go underneath that shell. This is the largest heat shield that we've ever built to protect this massive rover. It's 4.5 meters wide. You can see the technician up at the top there looking, and it's out of an entirely new material, a material that we've never sent to another planet before. So we had to build the largest aeroshell and the largest heat shield, and then on the top of the aeroshell, we had to attach the largest parachute that we've ever built. This is the largest disc gap band parachute that's ever been built. And it's 50 meters long and 15 meters wide, and you can see one of the engineers who was responsible for building that parachute looking up at it and thinking about how it will land on the surface of Mars. But we still didn't know this parachute only gets down to 300 kilometers per hour. We didn't know how we were going to get from 300 kilometers an hour to a nice soft touchdown on the surface of Mars. And what we did know is that the airbags that we'd use for Pathfinder, for Spirit, for Opportunity wouldn't work. They'd just be too big, too massive for us to launch to Mars. And a legged lander like Viking would get us all the way to Mars, but then we'd have to drive a 1 metric ton rover off the top of a legged lander, and we'd worry that we'd get all the way to Mars only to flip it over when we actually got there. So we came up with this. Instead of putting the rockets underneath the legged lander like Viking, let's build a lander where we put the rockets on top. like a jetpack. Only the problem with that is that once you land on Mars, you have a jetpack stuck to the top of your rover. And so we needed to figure out a way to actually get the rover out from underneath the jetpack. So we came up with this idea that we were going to lower the rover down on a string underneath the hovering jetpack and then cut the jetpack and let it fly off. This idea came from Genesis from a sky crane helicopter design. And we actually called this maneuver the sky crane maneuver. And so now we had all the pieces. And so the mission looked like this. We launched out of Florida, and we spent 9 months traveling to Mars, protected in this aeroshell that we had built. And it was protecting us from the harsh radiation environment of space, from the extreme temperature swings that you see in deep space. And we had solar arrays that were attached to this to be able to give us power as we traveled there. Now, even just getting to Mars is an unimaginable feat in and of itself. We launched from Earth, which is hurtling through around the sun. From one moving object to Mars, which is also traveling around the sun, another moving object. If we hit Mars too steep, we'll burn up in the atmosphere. If we hit Mars too shallow, we'll skip off the atmosphere and go out to deep space. So we had to hit it just right. And we're coming to Mars, we're traveling 5.4 kilometers every second. We're going quite literally faster than a speeding bullet when we come in. The heat shield that we built glows like the surface of the sun. And we have to steer this craft through the Martian atmosphere because the Martian atmosphere is too thin to just slow us down by itself. So much like a skier going downhill, we have to control the craft as it goes through the atmosphere of Mars. About 11 kilometers above the surface, we deploy the parachute, going Mach 1.7. And now, for the first time, we actually deploy this parachute on the surface of Mars, this largest parachute that's ever been built. And it slows us down to that 300 kilometers per hour that I mentioned before. Now, when we're hanging on the parachute, there becomes this moment where we actually have to decide when we're going to cut the cord and jettison the parachute, the safety of the parachute. Because we know if we ride the parachute too long, we'll crash into the surface of Mars at a suicidal 300 kilometers an hour. But if we separate too soon, we won't have enough fuel to be able to get down to the surface of Mars, and we'll crash. We'll run out of fuel, and we'll crash into the surface of Mars. So there's this moment at about a kilometer above the surface where the rover cuts the cord and jettisons the parachute. Now we're in propulsive flight. We free fall, and then we fire the 8 rocket engines that are attached to this rover on the jetpack, and we start to descend slowly to the surface of Mars. Over the next 30 seconds, we will have to slow down from 300 kilometers an hour to 2.5 kilometers per hour so we can start the sky crane maneuver. 20 meters above the surface, we start the sky crane maneuver, we lower the rover down, and the rover now gets ready for touchdown. And then finally, if everything went right, we actually touch down softly on the surface of Mars at 2.5 kilometers an hour. But even now, we're not done. We have this hovering jetpack over above us telling us that if we don't cut the cord, that jetpack's going to run out of fuel and crash down on top of us. So much has to go right in order for this to work. We have to have 76 different explosions, controlled explosions, work right. All of these controlled explosions have to be coordinated by the rover's onboard computer. And all of this has to take place completely out of touch with the Earth. At the speed of light, a signal sent from the rover takes 14 minutes to reach Earth. And the whole entire landing sequence that I just walked through is over in 7 minutes. Which means by the time that we hear that Curiosity is entering the top of the Martian atmosphere, it has either been safe or not on the surface of Mars for 7 minutes. Now, to control all this, we had to build smarts into the rover. We had to build software in order to teach the rover how to land on Mars. And so my team delivered over 5 million lines of software code to make this rover work. Now, all of that had to work perfectly. And what we knew was that a third of all the missions to the Red Planet have failed. A third of all the missions that have attempted to land on Mars have met with failure. And we only had one chance. We can't test this all together. There's no way to test the rover and the parachute and the aeroshell and the heat shield and to really put it through the conditions that it will see on Mars. The only time that the whole system will work is that one night in August when we land on Mars. And so even though we had run millions and millions of simulations on supercomputers, even though we had deployed our parachute in the world's largest wind tunnel, even though we had taken a torch and burned our heat shield, we didn't know whether or not all of that would work together. And as I walked into the mission control on August 5th, I was just reminded of the history of Mars. There comes a time on that last day where Mars you enter the gravity field of Mars, and Mars starts to pull you in. And so we have this moment where you remember all of the times that you were confident in the past and all of the times that Mars surprised you. And so you don't know whether or not that day is actually going to be a success. All you really do know is that you can't fully understand Mars. The Mars that was glimpsed by Mariner, the Mars that was explored by Viking, Pathfinder, Spirit, Opportunity, and Phoenix, they told us a lot, but what they really told us was that there's so much more about Mars, and there's so much uncertainty that we really don't know how it's going to go. And so that night, here's what happened. Here's a short video of what happened.
Things are looking good. Coming up on entry. Vehicle reports entry interface. At this time, it'll begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do. We are standing by for guided start of guided entry. We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. We have seen peak deceleration. It is starting its first bank reversal. It is reporting that we are seeing G's on the order of 11 to 12 Earth G's. Bank reversal 2 is starting. We are now getting telemetry from Odyssey. We should have parachute deploy around Mach 1.7. The parachute is deployed. We are decelerating. Speed chill has separated. We're found the ground. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending. Standing by for back shell separation. We are in powered flight. We're at altitude of 1 kilometer descending. Standing by for sky crane. Sky crane has started.
Signal to us, you remain strong.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us.
Got thumbnails.
Still gives me goosebumps to watch that video. And so here was one of the first images we got back from Mars. And I remember seeing this image, and this is when it really was real for the first time. You get that indication that you touched down safely, but it's not until you can really see the shadow of this rover that you built sitting on the surface of another planet that you really feel that connection to this exploration. And after this image, there were many great images that followed. We looked further at this mountain that we landed at, this 5.5 kilometer tall mountain that rivals some of the tallest mountains on Earth, Mount Sharp. And so this was the target where we're going to go and explore for our mission. And so we had these great views, these never-before-seen views of Mars. But of course, we got there, and we took these pictures, and what we realized was we're by ourselves. And so we did what I've seen so many tourists do. We took out our camera, and we held it up, and we took a picture of ourselves. And so here is the first self-portrait of a rover ever taken on the surface of another planet. And there's images that you have that you just, as soon as you see them come down, you know that they're going to be an iconic image of the mission. And so here, this was an image where the world's most complex robot that we've ever built to explore this planet, the surface of another planet, here it was, sitting safely on Mars, ready to do its job. And I can look at this image and I can just think about all the people that went into building this rover and making it successful. But we didn't just take pictures of ourselves. On the 40th day of the mission, we took this image, and this image gave us another important piece of the history of Mars. We learned that from this image, what looks like a sidewalk tilted up out of the soil is actually an ancient stream that's been maybe by an impact crater moved and moved to this angle, where now we can see that there's actually rounded rocks in here. And it's an evidence, our science team found this is evidence of flowing water on the surface of Mars. The first time that we have direct evidence that water actually flowed on the surface of Mars. And well, we came to this mission to get our hands dirty. And so it wasn't enough to just take pictures. So here we have the first image where we actually reached down and scooped up a soil sample of Mars. And what this allowed us to do was to feed this soil into our instruments for the first time and get images like this. This is an X-ray diffraction pattern where we blasted that soil with X-rays. And from the way that those X-rays diffracted as they hit the soil, we can actually tell the mineralogy of the soil sample. And we're learning new things about Mars with each one of these new experiments that we have. Now, this is going to be a long mission, and there's been much excitement over the past couple of weeks about new discoveries by this mission, new single discoveries, new single samples that might tell us whole new things about Mars. But there's the story of Mars has many chapters, and it's going to take us a long time to really to learn and to read all of those chapters and be able to say whether or not we really landed a place that might have the building blocks that we need in order to say whether or not there once was a possibility of life on Mars. But there's some images that came back from this mission that I think connect with us more fundamentally. And this, as we're going to take our first soil sample, as we're going to take that first scoop, we took a little scuff with our rover wheel just to see what the soil was like. And it's this image where I can really feel like I was on Mars, and I can just imagine taking my boot and doing a little scuff of the soil in front of me and really connecting with this rover. You know, this rover isn't just a cold robot that's sitting on the surface of another planet. It's part of us, and it connects with us. And when I see this image, I actually think back to the image from the exploration of the moon from Neil Armstrong, this first boot print, that really connects us to this exploration. On the night that we landed on Mars, there were over 1.8 billion hits on NASA's website. And this speaks to something that's much more fundamental about this exploration. This exploration isn't just about images, it isn't just about science, it isn't just about engineering feats of landing on Mars. There's something fundamental about ourselves that comes from these sorts of missions, and something fundamentally that makes us want to connect with each other, to engage in this exploration. And so here's where the story of Mars really connects with what we're doing this week. There were 1.8 billion people that went off, 1.8 billion hits. We had unique visitors from almost every country on Earth. And I think it speaks to something that is inherent in our own selves, something that's instinctual. In fact, one of the things that I get to do as the lead software engineer is there's a packet that gets sent back to Earth every time the rover has nothing to say. In this packet is 1,000 characters. And we really had no specification on what needed to go into that packet. It's just fill data. And so I did what any one of you would have done, is I said, okay, I have 1,000 characters to play with. It's fill data. I can put whatever I want in it. I'm going to put my name in it. So I put my name in it, and I put the names of all the developers that developed the software in it. And we put into that software, into that fill, that fill packet was now sent across interplanetary space and from the surface of Mars over 1 million times. But what was also in that fill packet was a quote from one of the founders, one of our forefathers of space exploration. And I think it speaks to what we're doing here. It says, exploration is in our nature. We began as wanderers, and we are wanderers still. We've lingered long enough on the shores of this cosmic ocean. We are ready at last to set sail for the stars. And it talks about how exploration is one of these fundamental characters within us. And so as we're here this week and we're talking about connected things and connected devices and connected objects, I think it's just as important to talk about why we connect. It's not just how we connect or what we connect. And we have this rover, which is the most distant connected object that we can have, which downloads images onto the internet right as they're taken. But why we connect is just as important. And here it is exploration that really caused this mass connection in for this mission. And so as you're building your services, as you're building the Internet of Things, think about, how can I fan that flame of exploration? How can I fan that flame of curiosity? Thank you.
Wow, Ben, that was a talk. That's so inspiring, incredible.
Thank you.
What is the single most exciting thing for you to be driving this adventure?
I think it's every new image that comes back. When we get a new image from Mars, it appears immediately on the web. There's this connection in this exploration that isn't just us sitting in the control room controlling this robot. It's the whole world is part of this mission. And being able to, for the first time, this was the first mission where we had actual social media, where we had a really social interaction, and we were able to hear from people all over the world and see how it connected them, how it directly touched them. And being able to inspire young people to explore and to pursue careers like this.
Talking about social media, we're #1 Twitter trend worldwide already. So it looks like your talk and the other talks from this morning are making some waves. Ben, thank you so much for joining us.
Thank you.
Thank you so much.
Thanks a lot.
Thank you.